Welcome in, everyone, to another episode of the Real Estate Tax Playbook, where we discuss all things real estate, providing timely and precise information to real estate professionals looking to build their own customized tax planning playbook. I'm your host, Evan Ross. I'm a tax director with Brown Edwards & Company, based out of our Roanoke, Virginia office. For those of you who are new to the podcast or have not had a chance to check out the Brown Edwards website, please do so at your convenience. A link to our website can be found in the description of this podcast. On the website, you'll find more information on our other service lines outside of tax, as well as our other locations and service providers. With all that being said, I would like to introduce to you our guest for today. We got a good topic for you, something very intriguing and timely. Dr. Luke Liska with Radford University. Dr. Liska, thanks for being with here today.
Thank you for having me. It's great to be here.
Yes, it's great. So, and obviously the first time I heard you speak was obviously at the Business Council event at the University Club at Virginia Tech not too long ago. Shout out to my alma mater, Virginia Tech. But I really appreciate the insight you gave on AI, artificial intelligence, and how you really grabbed on to the audience, and there was a lot of questions. So I knew from hearing you that night, that I had to have you on the podcast. So I really appreciate you coming on as a guest.
Yeah, thank you. It's always great to talk about, emerging technologies, kind of seeing where the future is going to go to. So I'm excited to be here.
Definitely. Well, before we get too into the meat of the conversation today, I want to give you an opportunity to just introduce yourself, kind of your background and what you do at Radford University.
Yeah, so I am an assistant professor at Radford. I've been here for 4 years, and I'm also the director of the Davis College Fellows, which is our business program's program of excellence. So basically, that program is all about connecting our students with, local business leaders and alumni all across, the United States, from New York City down to Nashville to Austin, Texas, things like that. So I'm really involved with getting students and making those connections for them. From an academics perspective, I teach creativity and innovation. I teach creativity in business. I teach predictive analytics and data mining. The last 2 are at the MBA level, which ironically, the creativity and innovation is at the freshman level. So all the way from freshman all the way up to seasoned veterans. But my research is typically in the side of consumer behavior, but my expertise is in digital marketing, which kind of is, I think, is where I've become the artificial intelligence kind of guru in my area. Of course, at Radford University, we have some people who are more deeper into the weeds. I kind of see myself as someone who is in between, right? I'm new enough. I'm not a computer science whiz, right? So I don't think about things in ones and zeros, right? But I do understand it so that we can talk about it and have really, figure out where the insights are and how we can use this to, better help both consumers and businesses.
That's great. That's great. Yeah, I actually, I was driving through Radford not too long ago, and it's just incredible to see all of the changes and development that's happened, not only on campus, but out towards Interstate 81, as well as in downtown Radford. My wife, she actually went to school at Radford years ago, so it's great to see the changes that have happened, all for the better, in the last 10 to 15 years.
Yeah, I'm so excited to be here, and I think everything's just looking up from here. So it's a fantastic place to be.
Awesome. Wonderful. Well, with all that, let's go ahead and dive into the topic for today. Obviously, we kind of alluded to it earlier. So AI, artificial intelligence, is going to be our topic for today. Obviously, there's a lot of different feelings around AI, a lot of excitement, confusion, curiosity, maybe even fear related to AI. So can you kind of just give, just from a broad scope, kind of how AI works, when it started, and why has it become so prevalent in the last 5+ years?
Yeah. So anytime I have a talk about AI, I think the best way to start with is a little bit of history of AI. I think that starts with what is AI, right? So put simply, AI is really any system that mimics human intelligence. And so from that perspective, AI has been around since the mid 1900s. Think you remember Alan Turing, the Turing test?
Yes.
So
Yes.
it's kind of the classic, is a machine indistinguishable from a human, right? And so that was developed in the late 1940s, early 1950s. And from that, we got into this concept of rule-based systems, which was just a influx of if-then statements. So if we were to play a game, let's say that we're a robot, right? And we have to follow a set of rules. So if I say it's raining, what would you typically say to that?
I need an umbrella.
Exactly, right? It's raining, need an umbrella. How about it's cold?
I need a jacket.
Need a jacket. And how about it's sunny?
I need my sunglasses.
Yep, need your sunglasses. And so if you had a robot that you asked those questions, you could program it to give you those responses. But does the robot itself understand what rain is, what cold is, and what sun is? They really don't. They just follow the rule book. And so that was the kind of the first iteration of what AI was, this classic if then statements. And then in the 1980s, we jumped into this idea of rule-based expert systems. And so it's this rule book that's designed by experts in the areas. And that allows, instead of saying, is it raining, take an umbrella, you could have a rule book specifically for, lack of a better topic, real estate tax. And so you could ask the computer any question about tax, and then it could respond to it. But the problem that arose in the 80s, and kind of why we had what's called like an AI winter, is in the real world, problems are very complex. It is never as simple as if, this, then that, right? And so you combine the complexity of those real world problems with the lack of computing power back in the 80s. I mean, that was before the internet really existed. And then from the 80s, we jump into the 90s. And so this concept of AI has been around, and people have gotten excited about it, but they haven't really done much with it because of these issues, right? This computing power issue and the complexity of real world problems, and being able to solve that with some sort of rule-based program. And we get into this concept in the 90s called machine learning, which I'm pretty sure a lot of us have heard of machine learning, right? It's thrown around all around the place. And basically machine learning is an algorithm that learns from data. So it no longer needs to follow those predefined rules. That rule book, kind of becomes this loose interpretation of what rules might be. And so this is the period of time where, do you play chess by any chance? Or
I do to some extent. I don't have as much time anymore. Let's say I'm more of a checkers guy. I have two young children. I have have an almost 7-year-old, so checkers is more of hers. But yeah, I have played chess.
Yeah, and so that's, in the 90s is when we built a computer or a machine learning system, IBM's Deep Blue, that was able to actually beat the world chess champion, which at that time was Garry Kasparov. And so, that's again, people got excited about AI. And so a machine learning is so here's AI up here, machine learning is below it. And so people got excited, but again, we had kind of this winter where they got excited, then they kind of lost excitement because, I can beat, the world chess champion, but can it do my taxes? And at that point, the answer is no. And then so in the late 90s, early 2000s, that Y2K era, what do you think happened?
There's a lot of change during that time. The new millennium. I mean, a lot of technology advances.
And I always joke with my students, the internet was invented by Al Gore. And because of that, we had this rise of data, right? Instead of everything being kept in paper portfolios, this is when we started to store data online, and data became more accessible. And this is, my love for digital marketing comes from this idea that in digital marketing, it's the one place where we have data to support almost every decision that we make. And as a marketer, a lot of times you go by that gut feeling, right? But being able to support everything with data is absolutely amazing. And so jump forward again, we're like the gaps between those AI winters were large, but now they're getting smaller and smaller and smaller. And jump forward a little bit to the 2010 era, where machine learning then became what's known as deep learning, which deep learning is basically the use of neural networks, which, of course, were inspired by the human brain. And these neural networks, easiest way to think of it is just layers upon layers of knowledge. And so it's a bunch of individual nodes that layer together in, operationalized as a mathematical model, right? And all of this was made possible because of advances in GPU power. I don't know if you play. I play a lot of video games. I coach the League of Legends team here at Radford as well. And the ability to just grab any GPU nowadays and have, maximum frames per second is incredible. And so while GPUs were, in a way are developed for gamers, since around 2010, we've really started developing GPUs also for, machine learning and for these deep learning models. And so combine a lot of GPU power with these large data sets, and all of a sudden you can kind of see where we're heading, right? We're getting this ability to evaluate more complex problems instead of just these basic rule-based systems. And so now we get to today's era, right? The reason that everyone is suddenly excited and, like, as you put, afraid of AI. I think of it as the 2018 to the present. And yes, we have advances in GPU power. Yes, we have greater access to data. But the main reason that we ended up where we are today, where we're really considering it, like we use and want to use AI in our everyday lives, is this concept called a transformer-based model, which is a type of neural network architecture. And so I want to break that piece down a little bit into kind of fun examples. I think talking about and understanding what a transformer-based model will make AI less scary, and also make us understand it more. So transformer-based models had three major kind of advancements that have revolutionized this machine learner, deep learning, AI, piece that we've kind of worked on. And so that is parallel processing, self-attention mechanisms, and also positional encoding. So if we're talking about parallel processing, typical models start from A, right, and go all the way down to B. And so imagine a puzzle. If you were a traditional model, you would put together that puzzle by yourself. And if you had 1,000-piece puzzle, how long do you think it would take you to do that puzzle?
Hours.
Hours, yeah. So now imagine you have 10 friends or 20 friends, and you're putting that same 100-piece puzzle together. How long would it take you now?
It's obviously going to go a lot faster.
Yeah, exactly. And so parallel processing basically means that we can evaluate all of this data that we have at the same time. We're processing it in parallel instead of having to read it across the line. And so from the other kind of advancement, it's that thing called self-attention or self-attention mechanism. And so if we had this, I have this example here. Alice gave her friend a gift because she was thankful. So when a computer is reading that, how does the computer know who she is? Right? Alice gave her friend a gift because she was thankful. Who is she? So to understand what we humans would do is we'd look back and say, okay, well, she is Alex, and Alex is her friend. And so that lets us understand who she is, right? And that's exactly what these transformer-based models do. They position all of the text in context to the other words around them. And so it allows them to have this concept of understanding that typical models didn't have. And so you could imagine it as imagine you're reading through something and you're underlining keywords and you're highlighting keywords. That's kind of what these transformer-based models are doing. And so just like, if you read a sentence and it was missing some words, typically you can fill in those gaps. That's kind of what's happening here, right? It's understanding the relationships and filling in those gaps. And then the last piece is this idea called positional encoding. And so this is where, if we go back to our puzzle, you know, would you say puzzles have a order in which they need to be put together?
I
Like,
would say yes. There is a strategic way you should be
yeah,
assembling a puzzle.
yeah, and you could, and I mean, I guess you could like jam all the pieces together, right? And you would get a semblance of what the puzzle's picture was, but it would definitely would not be the puzzle that you were supposed to be putting together. And so these transformer-based models solve that with something called positional encoding, where yes, they're reading all the words at once, but they're also coding all the words in their relative location to all the other words, which would basically be as if you'd labeled, once you finished a puzzle, you're labeling the puzzle pieces from 1 to 1,000. And that way you know where all the individual pieces lie and you can relate them to each other. You can say puzzle 1 is next to puzzle 3. And so when we combine all of these things together, we get, we get enhanced natural language processing. We get these GPTs, right? Everyone's heard of Chat GPT. It stands for Generative Pre-trained Transformer. So it is a generative, meaning it can make new things. You talk to it, it gives you new text. It's pre-trained because it's been trained on, books, websites, data it can find on the internet. And of course, we can fine tune a lot of GPTs, which means fine tuning means giving it more data that's more specific to the problem that we're trying to solve. And then transformer is just what we just talked about, right? A model that processes in parallel, everything at the same time. It has self-attention mechanisms and also has positional encoding. So it knows where all the pieces are meant to fit together, and that allows it to kind of make inferences and allows it to understand the whole context better. So you could think of it as, imagine you have a friend, and that friend can read an entire library's worth of books all at once, all at the same time, and remember with, perfect, or was it crystal clear memory? What's the I'm dropping the word. What's the word for having perfect memory?
Oh, perfect recall.
Yeah,
Or
I think it's perfect recall. But basically, imagine your friend has perfect recall, right? They can remember every single word that they've seen at any one time, right? Similar to there's a Netflix show with a kid who does this. Oh, what is it called?
I'm trying to think.
It's the lawyer one.
Oh, it's a is it Suits? No, not Suits.
Yeah,
It's
Suits.
is it Suits? No,
Yeah,
well,
yeah,
is that it?
yeah. It's Suits. It's the
It's got Harvey's the
yeah,
main character,
yeah.
the
Not
attorney.
it's the
So
one under Harvey,
yeah,
who kind of got his job because he memorized the law book, and he asked Harvey to open to a random page and start reading, and he actually finished the random page that he was reading because he had that picture memory, right? That perfect memory.
yes,
And so
yes.
that's what these GPTs are. They have perfect memory. And so when we ask them questions, they can go and look at everything all at once and kind of make these relational inferences, which is much harder for us to do, right? We kind of we have selective memory. We train ourselves with our jobs and our education to focus on a certain subset.
And I feel terrible. I feel terrible that I didn't know that character's name. His name is Mike Ross in
Yes,
the
Mike
show,
Ross.
and I always make a joke that that's my cousin, but
Yes.
he's got perfect recall, and I obviously do not. So
Yeah.
anyway,
And
I had to look it up. That would have bothered me the entire time we were having a conversation.
yeah,
So
and it's funny because that's me as well. I always joke when I need to remember something, it always slips my mind.
yeah,
But then I'll randomly remember the license plate of some car like from 3 years ago that like cut in front of me because I thought it was cool. And so
yeah.
my brain is good at remembering things I don't need to remember. But yeah, so imagine your friend is Mike Ross, and you have 20 Mike Rosses, and the ability to call upon them at any time. That is and that is why everyone's so excited about AI. So it started with, very basic rule-based systems. We got into this concept of machine learning, but we kind of lacked computational power in these transformer-based models. And then going into, the deep learning, and then now that we have these transformer-based models, it's really, the research paper was written in late 2017. And so this is brand, and concepts of academia. This is cutting edge, like brand new technology. And so the cool thing about it is because you combine that with the rapid advancements in GPU power and processing power, and that's why we're able to have, ChatGPT every 6 months making some crazy advancement. I know we talked just a couple of days ago about the new advanced voice mode that ChatGPT has, and that's that wasn't available a month ago, right? But now you can kind of. I was talking to it in multiple languages, and it would switch different languages back and forth, and I was like, this is life changing.
Yeah, it's amazing that it changes. I mean, like you said, it's monthly, daily, something new is coming out. So it really is incredible.
Yeah.
Yeah, so that's a great insight on kind of the history and where we are now. I think all of our listeners are probably, obviously, our listeners are real estate investors, professionals. They're probably looking at, okay, how does this relate to my business? So let's just think about a real estate investor. They're always looking for ways to stay ahead of their competition, find the next great property, regardless of what their intent is with the property. But is there a way to create an AI algorithm that would allow you to maybe find undervalued properties in an up and coming neighborhood, locality, region that could help you make the decisions before your competition?
Yeah, and so this is actually kind of similar to predictive analytics. The differences would be that you're actually feeding or training the AI data ahead of time. And so there is a custom GPT called it's the Real Estate Investment Advisor. And so what it is it's trained on data in Toronto, specifically Canada, and they train it not just on, of course, like classic real estate data, but they put in like talks about sound investment advice. They put in research on, when you're investing in real estate, what are the things that you need to look at? What are the things you need to evaluate? Specifically, then they put in a lot of the data relevant to the Toronto area. And so what they built is they built this AI model that has been fine-tuned to the specific market so that it understands, how long does a house typically sit on the market? If it's in the city, I looked it up, it was like 7 to 14 days. And if it was in the country, it was 50 days. And so it allows you to kind of ask the chat those questions that maybe you would typically spend an hour trying to find research on or trying to like find that data. And so what someone might do, depending on if you wanted to kind of get really deep into the weeds yourself, you could train a model to, you put in as much public data as possible, but you specifically focus on the areas maybe that you're interested in. And then when you prompt that area, it can then evaluate, your prompt or look for areas that might, be places where let's say, to jump into an example. So imagine that, I say any data you can add to it. Let's imagine that we feed satellite imagery and Google Street View into this AI, and we use this computer vision to actually analyze changes, computer vision plus some sort of geospatial data, right? Well, using AI, we can rapidly detect if there's any like changes to a neighborhood, such as improvements, a newly developed park, some sort of residential complex, maybe there's a new target, and it can do that across a wide area. And so this is, if you were doing that as a human, you'd have to kind of go by memory. Oh yeah, I remember that this place is now, they have this new park, they have this new Walmart, and because of that, it's probably going to be a hot real estate area in the next 5 years as people try to move into that. But if you instead use AI to evaluate, 100-mile square foot radius of changes to try to see, okay, where's the location that's going to be hot in the next 5 years because of the improvements that are being made, then that allows you to maybe identify the areas that will be hot, but that haven't rose in price yet, right? People haven't realized that that's a hot market. And that's something that if you did that as a just manually, you kind of have to have a single person devoted to that entire job instead of having, this transformer based model do it for you.
Yeah, creates a lot of efficiency. Another item I think about, so investors, developers, they purchase a property. They may not know what they want to do with that property. Do they want to hold it long term? Do they
Hmm.
want to flip it, turn it over in a couple months? Is it going to be a commercial space or a residential space? Are they going to invest in historic tax credits? So there's a lot of different considerations for an investor to make. Could AI assist with kind of figuring out what's going to give you the maximum return, give you scenarios, and kind of help you make that decision without just making a judgment call, more or less?
Yeah, and so that comes down to so regular ChatGPT could actually really help, but you could custom train one with, let's say, data on renovations. How much does it typically cost to renovate this kitchen? And you could feed it images of kitchens before and after renovations, how much it cost, and then you could also feed it data based off of houses, how much they were listed or sold for before or after a renovation. And so when you feed it all, train it on all of that data, then what you might be able to do is you could take a picture of a house or send it the listing data with all the images and say, process this data, let me know what you think could be renovated that would increase the value of the house. And that's something that if you were to do that specifically by yourself, you'd want to hire a computer scientist, right? And try to really build out that sort of platform. But you could also do that from a generic standpoint, just using ChatGPT. It wouldn't be as specifically accurate if you actually had a lot of that data. But what's really cool about that is then you might say, okay, AI estimates that based off of the pictures of this kitchen, it's going to cost $30,000 to renovate, and it's going to increase the value of the house by only 25,000. And so in that case, you would decide not to renovate, right? Because you would basically save $5,000. But it could be the flip side. It might only cost $20,000 to renovate, and it will increase the value by 30,000. And what's cool is since AI has parallel processing, right? And it can look at all the data all at once, it can make those inferences to help you figure out that relationship between, how much something might cost to renovate and how much you might be able to sell it for afterwards.
Yeah,
Um,
that's the
it
kind of
all,
information. That's the kind of
yeah,
information that listeners obviously want to hear. So I think a lot of people will be interested in, if they haven't already tried AI, looking
yeah.
into it.
And it's funny because I'm actually on the market right now. We're
Okay,
buying, selling a house, and so I've been using AI to help me kind of come up with some of these decisions, which is kind of funny.
that's awesome. So yeah,
Yeah,
so for firsthand how this
yeah,
can be beneficial. So there's obviously probably some ethical considerations with this. Um, I'm sure you've seen it. I have as well, but I've seen a lot of lawsuits coming up lately. A lot
Mhm.
from news agencies, news platforms with copyright, plagiarism lawsuits. Can you just speak on kind of that and kind of the ethical considerations if people are
Yeah,
on the fence?
yeah, and I mean, that's a broader topic. I think the ethicality of using data, right? Because a lot of these AIs are built with data that isn't necessarily public data, right? There isn't necessarily free data. So that is definitely, a very hot topic. But I think that also specifically thinking about real estate too, depending on if you pre-train the model, the data you use outside of whether or not we can actually use the data that you use introduces a bias into the model itself. And so will that model bias cause some sort of discrimination, which is against the Fair Housing Act? And so the best thing that we can do as people using these models is trying to audit them. I think in the talk I gave a couple weeks or a month ago, I said trust but verify. So when you're using AI, you trust it to do the right job, but it's always important to verify its work. And so one thing that we can do is just to make sure that, if we start noticing trends that the AI is biasing towards certain decisions, is that being discriminatory? Is that something that we need to try to, tease out by maybe training the model with different data? Trying to, and that's because AI is this kind of black box. I think we feel that way sometimes. And of course, the other, I think, ethical piece too is this idea that is the market being manipulated by people using AI tools? Because I mean, Zillow actually is an AI tool. If you think, Zillow uses predictive analytics, advanced, machine learning to give you a valuation or estimate of your house. And a lot of, typical normal people who are buying houses, they might use that as an estimation of what they should offer. And so that, in and of itself is a semblance of market manipulation. And so as a real estate investor, you need to understand, okay, how is Zillow affecting all these buyers that are looking to buy the houses that I'm trying to sell? Maybe it's being positive for your bottom line, but maybe it's not. And so these are all questions that I think when it comes to ethics, it's really important to like think about and consider, and see what are ways that we might be able to mitigate the effects that, these might have on me. Which is, it's kind of like, do you remember Midjourney when it first came out, the AI image generator?
Yep.
And so I remember Midjourney, it was really cool at first. And then what happened was, over a course of a month, it started training itself on AI generated images. And all of a sudden, it went from making really good images to like really bad images because it was training itself on AI. So it was kind of just slowly diluting itself. And so the developers had to go in and kind of fix that, right? And so that's something that, if everyone is using some sort of AI tool to make real estate decisions, over time, that is going to bias decisions one way or the other. And we need to make sure that we as humans adjust for that, and make sure it doesn't affect us negatively.
Yeah, hopefully this conversation has kind of opened people's eyes a little bit. For people that are kind of still on the fence, what would you say to kind of encourage them to at least give AI a try? Obviously, it's not going anywhere. It's only going to develop more and be more involved in our day-to-day life. So what would you kind of say to those people that are still on the fence, haven't made a decision to make that leap?
Yeah. And I think when I think of AI, I think of it as efficiency and enhanced decision making, which means two things. You're going to save time and you're going to save money. And what's really cool about generative AI is that there's a very low barrier of entry. You can use ChatGPT for free. You can use Gemini for free. You can use Claude for free. Or you could pay $20 a month and get the advanced, all the latest, greatest advancements all at once, which is pretty cool as well. And the exciting part about that is there is a high ceiling to that. You can pre-train your own models. You can really adapt AI to be very specific for your use case and your need. The issue with that is it does become technical, right? It is something that is more challenging to do. But what it means is that anyone can use AI. Anyone, as long as you can use a computer or a cell phone, you can open up ChatGPT all the way over here to, a computer scientist who's training a model specific to, the needs that they have. And I think we talked about this at the talk as well a couple months ago, or a couple weeks/month ago.
Yeah.
Is that the future is going to be a human using AI is where the future's heading down. It's going to be, a lot of people are afraid of, losing their jobs to AI. And I think we don't need to worry about that. At least not until we get, not until we figure out quantum computing do we really need to worry about something like that. But the future is humans using AI because they're more efficient, and they're, the decisions that they make are better informed. Because AI, again, these transformer-based models allow us to do this parallel processing, which is something that we humans are bad at. Which is why earlier in the podcast we struggled to figure out Mike Ross's name, because we don't have the ability to just hold all of that knowledge in our mind all at once. But these AI models can. And so I think if someone's, really hesitant about it and wants to get in it, the best thing to do is just try. Think about what problems do you have what are things, you might have a specific goal and AI might be able to help you reach that goal. And so the best thing that you can do is try to see if AI can help you actually reach that goal. And when you use AI and you don't get the response that you really want, I said this in the talk as well, you want to make sure that you ask it a different way. You want to add as much detail as possible to your question. Because if you ask AI a very generic statement, like you could send it a listing and say, should I buy this property? Like it's very generic, right? But maybe you could add some detail into that question. Tell them your budget, tell them why you're interested in that property. Um, Maybe feed them some of the comps that you have around the area, and then say, do you think this is a good investment advice to buy this property, or should I do something else? And you can actually give an example of the alternative that you might do. And so in that particular case, something like ChatGPT is going to be able to be better informed to answer your question because you gave it so much more detail about the problem that you're trying to solve. And a lot of people who use AI and end up going away from it, it's because they just ask it a very simple question. They're like, yeah, I don't like the answer. But try, really get into the details, get into the weeds a little bit yourself.
Yeah. So I mean, yeah, obviously you get, like with a lot of different things, you get out of it what you put into it. So
Yeah, exactly.
if you're asking basic questions, you're going to get basic answers. If you ask more well thought out, detailed questions, you're going to get better answers from AI. So a lot of good insights today. I really appreciate you coming on. I would like to give you the opportunity before we wrap up the episode, if you can provide your contact information, if people do have follow-up questions related to AI and just want to know more or talk to you in more detail on how this can help them and what this or that looks like.
Yeah. And so funny enough, I think the best way to contact me, and I'm doing it right now, if you Google Luke Liska, then my Radford University page comes up as the #1 result. My LinkedIn page comes up as my #2 result. And then my faculty and staff page comes up as #3. And so Google that. It'll have my or Google Luke Liska, LukeLiska, and it has the most up-to-date contact information on there. And I will say my most preferred method of contact is LinkedIn, probably. It's really easy to kind of have conversations on there, but also my email address is lliska@radford.edu.
Very good. Thank you very much. And for any of those wondering if these podcast episodes are scripted, they are not, as judging by that question that came up about the Suits Netflix show about Harvey and Mike Ross. So anywho, well, that is a wrap for this episode of the Real Estate Tax Playbook. Again, as always, I appreciate all of our listeners for tuning in. If you like what you're hearing, please make sure you subscribe wherever you get your podcast. Also, feel free to tell your friends, colleagues, whoever it may be, to tune in if they have any interest in real estate investing and development. We love for them to listen and grab some of this content. So that is it for today. We look forward to bringing you more content in the future. Take care.